Covalent bond. Consider the formation of chlorine molecule. Each chlorine atom has 7 valence electrons and each chlorine atom requires one more electron to get octet configuration. Therefore, each chlorine atom contributes 1 electron for sharing with the other atom. Since 2 electrons are shared between 2 chlorine atoms, a single covalent bond is formed. Now consider carbon dioxide. Carbon has 4 valence electrons. Each oxygen atom has 6 valence electrons. Each oxygen atom requires 2 more electrons to get octet configuration. Therefore, out of 4 valence electrons in carbon, 2 of them will be shared with one oxygen atom and the other 2 electrons of carbon will be shared with the other oxygen atom. You can see that each oxygen atom contributes 2 electrons for sharing with carbon atom. Thus, carbon gets 8 electrons around it. Since 4 electrons or 2 pairs of electrons are shared, a double bond is formed between carbon and oxygen. Such 2 bonds are present in carbon dioxide. Next, consider water H2O. Oxygen has 6 valence electrons, hydrogen 1 electron. So each hydrogen requires 1 more electron and oxygen requires 2 more electrons to get octet configuration. One pair of electron is shared between oxygen and hydrogen. Therefore, a single bond is formed. 2 such bonds are present in water. 2 single bonds are present in water. In a similar way, we can find that a triple bond is present between 2 nitrogen atoms in nitrogen molecule. Next, consider Ethene C2h4. A double bond is present between 2 carbon atoms since 4 electrons or 2 pairs of electrons are shared between 2 carbon atoms. The carbon-hydrogen bond is formed by the sharing of a pair of electrons between carbon and hydrogen. Next, consider Ethyne C2h2. In ethine, a triple bond is formed between the 2 carbon atoms due to the sharing of 3 pairs of electrons between the 2 carbon atoms. The carbon-hydrogen bond is formed by the sharing of a pair of electrons between carbon and hydrogen. Thus, in chlorine molecule, since one electron pair is shared between 2 chlorine atoms, a single covalent bond is formed. Now consider oxygen molecule O2. Since 2 pairs of electrons are shared between 2 oxygen atoms, a double covalent bond will be formed between 2 oxygen atoms. Now consider nitrogen N2. We can see that 3 pairs of electrons are shared between 2 nitrogen atoms. Therefore, a triple covalent bond will be formed. Now consider carbon dioxide CO2. There are 2 double bonds present in the molecule. Each of the double bond is formed by the sharing of 4 electrons or 2 pairs of electrons between carbon and oxygen. 2 double bonds are present in carbon dioxide. Next, consider methane CH4. Here, 4 single bonds are present. Each carbon-hydrogen bond is formed by the sharing of a pair of electrons between carbon and hydrogen. Now, if we consider ethene C2h4, 1 double bond is present and 4 single bonds are present. The double bond is present between the 2 carbon atoms and it is formed by the sharing of 4 electrons between the 2 carbon atoms. 2 pairs of electrons are shared between the 2 carbon atoms. And each carbon-hydrogen bond is formed by the sharing of a pair of electrons between carbon and hydrogen. So 4 such CH bonds are present in ethene. Now consider ethyne C2h2. It has 1 triple bond and 2 single bonds. The triple bond is formed by the sharing of 3 pairs of electrons between the 2 carbon atoms and each carbon-hydrogen bond is formed by the sharing of a pair of electrons between carbon and hydrogen. So how is a covalent bond formed? It is formed by the sharing of electrons between atoms. If one pair of electrons is shared between 2 atoms, a single covalent bond is formed. If 2 pairs of electrons are shared, a double bond will be formed, and if 3 pairs of electrons are shared between atoms, a triple covalent bond will be formed. And as a result of bond formation or as a result of sharing of electrons, each atom acquires 8 electrons around it.